Hey guys, hope you guys are doing all right. Here is a video I'm going to post about how to solve the problems from that are in Delta Math. I know Lorenzo had asked about it yesterday, and there's probably a few of you that still have other questions. I had a couple students go over some asking me about these yesterday in class. So when we're setting up and solving exponential growth or decay problems in Delta Math, it's one of your assignments. You have to keep in mind first of all that there's two equations we're gonna use. It's either going to be y equals a times 1 plus r raised to the t when it's, let's use green for growth. Or if you have a decay problem, you're going to use y equals a times 1 minus r raised to the t power, where we said that a is your initial value or starting amount, r is your rate in decimal form, and t is your time. So let's take a look at this first problem that I pulled directly from Delta Math. It says, let me use the highlighters. $3,600 is placed in an account with an annual interest rate of 9%. So that's our rate. How much will be in the account after 25 years? So we've got our, let's try these different colors. We've got our A value, which is $3,600. That looks funky. Dollars. We've got our rate, which is 9%, which we need to convert to 0.09. Remember, to convert percent, you start here and you move this decimal place 2 over, 2 to the left. Okay. And the last one we have is t equals 25 years. So we're going to write 25 years. Now we need to figure out, do we use decay or growth? Well, it says it's placed in an account with an annual interest. How much will be in the account after 25 years? So if you're putting money and you're going to let it accrue interest over time, that means it's going to grow. So if it's growing, we're going to use the growth formula. And the only difference is, the only thing that changes between these two formulas is this plus or minus inside the parentheses. Okay. After this is just plugging the numbers in. Okay. We literally just need to plug the numbers in. Y equals 3600, 1 plus the rate, which is 0.09, and that's going to be raised to the, what do we got here, 25 years. So what you're going to do is you're going to take 3600, you're going to do this math inside. 1 plus 0.09 gives you 1.09. You're going to raise that to the 25th power. Now, when you're solving this, use a calculator. You have to be sure that you do the exponent first. So you have to do this first in the calculator. Or you can just enter this whole thing in the calculator. If you do it by hand or you're doing it in multiple steps, you got to make sure that you do the 1.09 raised to the 25th power first, and then you multiply by 3600. If you put it in the calculator, it will automatically follow order of operations for you. But please make sure that you include these parentheses when you type it into the calculator. You have to type it in exactly as you see it. 3600, the parentheses, and then raised to the 25th. Okay, that should give you some answer, and that's what you're going to type in here to the Delta Math. Okay, let me show you an example of a decay and what kind of keywords you're going to see when you're looking at decay. So what do we say? A new car purchased for well, I want the highlighter. A new car purchased for 17,900. Oh, it's a pretty good deal on a car. I guess I'd pay a little bit more for ours. So the value of the car depreciates. So this is the key word right here. depreciates. If you don't know what depreciates means, you may need to look it up. But you know when you buy a car, it's worth less as soon as you drive it off the lot. The price immediately goes down, the value of it goes down. If you have it for a couple years, the price really goes down a lot. So depreciate means, oops, what did I do? Depreciate means that the value goes down. So that's going to be a decay problem. And therefore, we're going to use this form of a times 1 minus r to the t. Okay. What are the other things we need to identify? The rate. Darn it, keep doing that. What will the value of the car be to the nearest cent? So let's keep track of that after 10 years. What's up, Bubbers? You okay? A equals 17,900. The rate, it's 12.25. We got to write that in decimal point, which is 0.1225. And then our time is 10 years. Okay, so now we got to plug these into the equations. 17,900 times 1 minus 0.1225 raised to the 10th power. Okay, again, all you need to do is plug all of this into the calculator. Let's see, 1 minus 0.1225 is, let me do that here with my calculator. That's 0.8775 raised to the 10th power. So the answer you should get, excuse me, 17,900.
With the dollars that you asked.
Oh, that's pretty slick. I like it. That looks cool.
For Henry.
Oh, nice. 17,900 times 0.8775 raised to the 10th power. And you should get an answer, 48,453. If you did not get this answer when you type it into the calculator, you're typing it in the calculator wrong. Okay, let me go back to this one. 3,600 times 1.09 raised to the 25th power. You should get something like, you should get 31,043 times 0.09. Okay. If you don't get these when you put that into the calculator, this equation, you're typing it into the calculator wrong. Okay, so please practice with that. Let's take a look at the next topic we covered was solving exponential equations with the same base. So remember, I did these in class as an example on Wednesday. What we had to do is we had to write these in such a way that they have the same base. So another way we can write 9 is we can write 3 squared. 3 times 3 is 9. And another way we can write 27 is 3 to the cube, or 3 cubed, because 3 times 3 times 3 equals 3 and 3 is 9, times 3 is 27. Okay. So we have to understand that first. Our goal here is to try to get everything under the same base. So now instead of writing 9, I'm going to write 3 squared, and then I still have, I'm having all this, right? So I'm going to write 2x minus 5 equals, and instead of 27, I'm going to write 3 raised to the power of 3. Okay. So what I'm going to do here is I need to use the power rule of exponents, which tells me that if I have anything, any number, any base raised to some exponent, whatever, it could be 2, 4, 6, 8, 1, 2, 3, 4, 5, and I have another exponent out here, all I need to do is multiply these two. So then that becomes b to the 6, okay? So when you have a number here, and it's raised to another number up here, all you need to do is multiply everything up here by this 2. So let me write that out. I'm going to write 3 and 2 times 2 is 4x. 2 times negative 5 is negative 10. And that's going to equal 3 to the 3rd power. Now that I have the same base, what winds up happening is you can actually cancel out these bases. There's another rule that allows us to do that. You cancel out the bases, and now I just bring down my exponents, and I set them equal to each other. Then I've got to bring this 10 over to the other side so I can solve for x. So we're going to add 10 to both sides. That winds up canceling out these two 10s. I'm left with 4x equals 3 plus 10, which is 13. Then I want to get rid of this 4, which I can do by dividing both sides by 4. That will cancel out these 4's, and I'll be left with x equals 13 over 4. Okay. The other examples, we did do these in class. I'll try to get those posted up. But that's the concept. That's kind of the steps that we followed, right? Now let me show you how to set those up. Let me show you one more. I'll show you one of the simple ones. So I want to get this 4 and this 16 in some format that they both have the same base. So let's start with the 4, okay? Another way I can write 4 is I can write 2 to the power of 2. Then I'm going to write my parentheses, and I'm going to keep my exponent the same. And 16, if I write it with a base of 2, what times what? How many times do I need to multiply 2 to get 16? Well, 2 times 2 is 4, times 2 is 8, so I need one more 2. Times 2 is 16, okay? 2 raised to the 4th power gives me 16. 2 times 2 is 8, times 2, 2 times 2 is 4, times 2 is 8, times another 2 is 16. So remember, the next step is I multiply this 2 by everything that's in this exponent. So I've got 2, oops, that's not what I want. I've got 2, and then I'm going to multiply 2 times 2, which is 4x. Let's write this in green. 4x, and 2 times 3 is 6. And I'm going to keep this the same so that I can come back and I can cancel out these two bases. And I'm left with the exponents that I'm going to set equal to each other. Okay. Now I want to solve for x by bringing that 6 over to the other side of the equation. I'm going to do that first, and then I'm going to worry back and come back for this 4. Okay. So let's do the 6 first. I'm going to subtract 6 from both sides so that my 6's cancel out on this side. Bring down my 4x. 4 minus 6 is negative 2. Then I'm going to go ahead and divide both sides by 4 so I can cancel out these two x's. And I'm going to be left with x equals negative 2 over 4, which is negative 1/2. Okay, so my final answer is x equals negative 1/2. Okay, so let me show you how to set up these delta math problems. I think I got one here. Okay, these are the same steps, same concept, but it's going to be kind of tricky because you got to figure out which one of these are kind of hard, right? There's a lot of there's a big number to figure out, and you need to figure out which base is common between the two. Okay, you need to figure out which base is common between the two. So what you're going to have to do is you're going to have to trial and error and kind of do some guesswork and figure out which way you can write this number and this number in the same base, which means you're going to have to figure out what are the factors of 7776 and 1296. Pause it. Okay. So what I find out through trial and error is that 6 raised to the 5th power equals 7,776, and 6 raised to the 4th power equals 1296. Okay, I'll look for some tables of exponents and see if I can find something useful so you guys will be able to use this on the quiz, so you're not trying to have to do all this guesswork. But let's go back down here. So instead of writing 7,776, I'm going to write 6 to the 5th power in parentheses. I'm going to keep my exponent the same. And then over here, I'm going to write 6 to the 4th power in parentheses raised to the 6x plus 2x plus 1. So now remember, I've got to multiply. No, not that. I've got to multiply all of this times all of this. And then I'm going to multiply this times all of this. I'm going to keep my base the same. So I've got 6. 5 times 2x is 10x. 5 times 4 is 20. And on this side of the equation, I've got 6 base, and 4 times 2x is 8x. 4 times 1 is 4. Okay. So here's the deal. The bases cancel each other out, and we can write the exponents equal to each other. Okay. Now this is just solving for x, isolating x. We've got 2 moves that we need to make here. We need to bring this 20 I don't want that. We need to bring this 20 to the other side. And we need to bring this 8x over to this side. Okay, so we're going to do like 2 different moves here. I can get this 20 over to the other side by subtracting 20 from both sides. That means these cancel each other out. I'm left with 10x equals 8x. 4 minus 20 is negative 16. Okay, I'm just going to rewrite this over here so I have enough space. So now I want to bring this 8x to the other side of the equal, so I'm going to subtract all together, the whole thing, negative 8x, and I'm going to subtract 8x from the other side. What that does is cancel this out. Sorry, I don't know if you could hear that downstairs. This dude's trying to fix our sliding door, and it's making a lot of racket. So I'm rewriting this. 10x minus 8x equals minus 16. 10x minus 8x is just 2x equals negative 16. Now I want to get rid of this 2, which I can do by dividing both sides by 2. My 2's cancel out here, and I'm left with x equals negative 16 over 2, which is negative 8. Okay, and that's what I'm going to type into this. I'm going to type, I don't think I need to type the x. I think I just type negative 8, and that should give me the answer. Okay, let's do one more together. Again, I'm going to try to find something for you guys as a resource to not have to be, oh shoot, this is the same problem. Okay, here we go. So you're not trying to like figure out what with all these exponents, but I'll give you a tip. If I look on this side, I know that ultimately all these problems are about the same base, common base. So I have to figure out how to get these under the same base. So let's look at this one because this one's easy. What times what gives me 25? How can I write this in an exponent? Well, I know the only one that really works is 5 squared, okay? 5 squared equals 5 times 5 equals 25. Okay. There's no other number I can multiply by itself to get 5. So then by default, this must be some kind of power of 5, or it should be 5 raised to some power. So if I trial and error, I'm literally just using my calculator here, and I'm doing 5 times 5 times 5 times 5 times 5 until I get 3,125, and that is 5 times 5 times 5 times 5 times 5 equals 3,125. So I have 1, 2, 3, 4, 5. I've got 5 5s, so I can rewrite that as 5 raised to the 5th power. Okay, so I'm going to come down here, rewrite everything. 5 raised to the 5th power. Keep the exponent the same. Equals 5 squared raised to the 3x minus 1. Okay. Again, I'm going to multiply all this by all this. Then I'm going to multiply all this by all of this. So I'm going to get 5, my base of 5. 5 times x is 5x. 5 times 3 is 15 equals, my base stays the same. I multiply this times this. That's 6x minus 2. Those bases cancel each other out. I'm left with my exponents equal to each other. Okay, now it's just solving for x. I want to bring this to the other side, and then I want to bring that over here. So I got to do like a couple different moves here. First, I'm going to work with the easiest thing here. Bring 15 on both sides. Those 15s cancel. I'm left with 5x equals 6x. 7 negative 2 minus 15 is negative 17. Now I'm going to bring all of this over here by subtracting an entire 6x from both sides. These cancel each other out. Remember, there's a positive 5 up here. So I've got negative 6x plus 5, or the other way I can look at it is 5x minus 6, which is negative x, equals negative 17. This is a good answer, but it's not going to accept that answer in Delta Math. What you need to do is, because we don't like negatives out here in the front of the x, so you got to multiply the whole thing by negative 1, which gives you x equals 17. Okay. And that's it. So then here you're just going to type 17. That'll submit your answer. Okay, good luck, guys. I hope you are able to solve these problems and complete the Delta Math. If you do need additional help, I can help you all on Monday when I get back. We can look it over. Next week, we're going to go really fast, Monday, Tuesday, and Wednesday, to finish out logarithms and what we need to learn for that. And then we're going to start our review for the exam towards the end of the week. Okay, thank you, guys. Have a good weekend.